First question we're going to take a look at is solving a triangle. So they're asking us if, let's see, it may or may not determine a triangle, and then if it is, they want us to figure out what law we can use to solve it. If it is law of sines, then they want us to try to do it. If it's not law of sines, then they just want us to stop and not solve it at all. All right, so first thing I'm going to do is I'm just going to call this beta, just so it's more in line with what we've done in class. I'm going to make a table. And how do we know from looking at this table if this is law of sines or law of cosines?
If one column is completely filled out, sorry.
One row. So we're looking to see if we have a full row. Do we have a full row? Yep, so then this is definitely law of sines. And then it says use law of sines to try to solve it. So we're going to try to solve it. If it ends up being impossible, then we'll write that down as well. Or we could have two answers, or we could have one answer. So this is a side-side angle case. So what do you have to solve for first when you're doing side-side angle? There's only one option of something we could try to find first.
Gamma.
Gamma. Because the row that's empty, that row is useless. Law of sines can only use a partial row and a full row. So let's find gamma. And we're going to write sine and sine. And what could I put on the left side? Yeah.
Sine 12. Oh wait, sine 111.
Yep, sine 111
Over 12.
over 12. And then what would we put on the right side to find gamma?
Sine gamma, and then over 8.
Yep. So now I'm going to multiply both sides by 8. That's going to give me 8 sine 111 over 12 equals sine gamma. And then how are we going to get rid of this sine to get gamma by itself? Yep.
Take the arc sine.
Yep, take the arc sine or inverse sine. In degrees, I want to make sure I'm matching what they gave me in the problem. So inverse sine of 8 sine 111 divided by 12. I have a feeling this is going to work, so we're not going to get a no solution. And it did work. So we get 38.491. And that's for gamma. Now, what do I have to subtract that from to check if there's a second answer?
180.
Yep, I'm going to subtract that from 180. I'm not saying there's a second answer, I'm checking. So if there's a second answer, it would be 141.509. Does that angle fit with the one they gave me? No. They gave me 111. There's no way I can fit 141 and 111. That's over 200. So in this particular one, we don't have to worry about the second answer, which is great. So we can finish solving it like a one solution. Any question on how we got the second answer or how we figured out it does not work? Okay, so then we've got these two angles. How can we get alpha now that we have 2 out of 3? Yeah.
You can take beta and gamma and add them and subtract them from 180.
Yep, I'm going to subtract them both from 180, which I can do just like this. Order of operations, it'll handle it fine. 30.509. All right, now we don't have any empty rows. That means we should be able to finish this off to find A. Okay, to find A, first we want to start with a row that has everything in it. We have 2 rows that have everything in it. Which row should we use?
The one with 111 and 12,
Yeah, how come?
because that was given to us.
Yep, that was given. We know those answers are right and they're exact. And what would we put on the right side to find alpha? So 30.509 over,
A.
yep. Okay, so we'll cross multiply. We're going to get 12 times the sine of 30.509. And then we're going to divide that by sine 111. Right. So that gives me 6.523. Okay, the biggest side is with the biggest angle. The smallest side matches the smallest angle. And any 2 sides added together look like they are bigger than the third. So everything looks reasonable. And that's a side-side angle. All right, next one we're going to take a look at is number 3. So let's make a table just to organize all our information. I also renamed capital A to alpha to be in line with how we did it in class. All right, so B is 14, C is 6, and alpha is 52. Okay, looking at that, how do we know whether we should use law of sines or law of cosines? Yep.
Because we don't have a full row.
Right, we don't have a full row, which means you cannot use law of sines. You can try, it won't work, so don't try. You've got to use law of cosines. And when you're doing law of cosines, we have to write down the version that has alpha in it. Does anybody remember for law of cosines, the version that has alpha? What letter does it start with? Yep.
Is it A?
Yep, a squared.
A squared equals, I don't know the rest.
And what comes after that? Yep.
14 squared.
Can you give me the letters first and then we'll plug in? Just so we can write
B
the formula.
squared plus C squared minus 2BC cosine alpha.
Alpha. Yep. And now we're going to fill all that in as much as we can. So A we don't know. B squared, that's 14 times 14. What's that, 190, is that 196? Yeah, 196. C squared is 36 minus 2 times B times C. Well, that's 2 times 14 times 6. It's 168. Cosine, alpha we already know, 52. Okay. What can I do next on the right-hand side?
You can add 196 plus 36.
Yep, you can add the 196 and the 36 because those are like terms. So that's going to give you 232. And without rounding, that's pretty much all I can do. Now I really want to just get A by itself. How do we get rid of this power of 2 on the A? Yep.
You have to square root.
Yep. We're going to square root it. And up until this step, I have not rounded anything. I'm going to round now. So the square root of 232 minus 168 cosine 52. Again, make sure you're still in degrees to match the information in the problem. And that gives you 11.6 11.339. Okay, so that's A. 11.339. All right, so now we've got all the sides. We've got to do law of cosines one more time to get the angle. But this is a good problem because the first time we went through it, we solved for the side. The next time we go through it, we're going to solve for the angle. All right, which angle do we want to try to find? Beta or gamma? Yep.
Maybe gamma.
Gamma, sure. So we're going to find gamma. And what does the law of cosines look like that has gamma? What letter does it start with? Yep.
C squared.
C squared.
C squared equals A squared plus B squared minus AB.
2AB.
Oh, sorry, 2AB cosine gamma.
Yep. Cosine of gamma. And we'll fill in everything that we can. All right, so C squared we can do, 36. A squared, I'm not going to take 11.339 and square it. I'm going to take the last answer that I had on the calculator and square it. Why do it that way? Yep.
Because it's more towards the exact number.
Right. It's more accurate because it's using all those decimal places. Maybe it's even using more that the calculator knows that it's not showing us. All right. So that's 128.569. Okay. We need B squared. Okay, we did that earlier. What was 14 times 14? 196 minus 2 times A times B. So 2 times A times B. Well, 2 times B is 28. I need 28 times 11.339. Okay, so we should get, 28 times 11.339. That's 2 times A times B. 317.492. All right, so now the variable is on the side with all the numbers, so we've got to simplify what we can and put everything on the left. What could I simplify on the right-hand side? Yep.
128.56, about 569 plus 196.
Yep, we can add the first two together. So that's the 128.569 plus 196. Right, 324.569. Okay, that's all we did in that step was add those two. Everything else is still where it was.
What was the number again on the calculator?
When we add 128 and 196,
Yeah.
324.569.
Sorry, I thought you wrote it wrong. I was mistaken.
Well, it happens. Sometimes I do. Okay, so we combine like terms. 3 steps left. What's my next step? Yep.
Subtract 324.569 from 36.
Yep. So we'll do 36 minus the 324.569. That's going to give me negative 288.569. So that's over there. So equals negative 317. All right, now 2 steps left. What's our next step?
Divide both sides by negative 317.492.
So divide by that negative 317. Don't do that out, because if you do it, you're just going to be rounding even more than we already have. So we'll divide It's gone from the right, the negatives are also gone on the left. And what would be our last step to get gamma by itself? Yes.
Inverse cosine.
Yep, take the inverse cosine. Bigger number should always be in the bottom, or you're not going to be within the domain of -1 to 1. Bigger numbers in the bottom, so we're looking good. 288.569 divided by 317, 492. Okay, so that gives you an angle of 24.646. 24.646. Now that we've got alpha and gamma, we can just add them up and subtract from 180, and that will give us beta. So 180 minus 52 minus 24.646. I know I'm not adding them up and subtracting 180, but I'm doing the same thing by just subtracting both of them from 180. Order of operations, that's fine. It's 103.354. In that particular problem, it covers everything that we have to know about law of cosines. Finding a side, finding an angle. If we had a side-side-side problem, it would just be doing this twice. Because you wouldn't have to find any sides, just angles. Yep.
Is there ever going to be a time that the bigger number isn't in the bottom?
When you're doing side angle side, if that happens, something's gone very wrong.
Okay.
Then we need to start over and figure out what mistake was made. Yeah. So no, that should not happen with side angle side. All right, so this one, let's just go through it one time. It's a side-side-side problem to find one of the angles. How do we know that this is law of cosines? Yeah.
There isn't a full row.
Right, there's not a full row. When you know all three sides, you can find any angle that you want first. We just did gamma, so let's do something besides that. Let's try beta. Can someone remind me what the law of cosines is that has beta in it? Yeah.
B squared equals A squared plus C squared minus 2AC cosine theta.
Yep. And we're going to fill everything in. As we go, we'll do some of it out because we don't have any decimals, so it shouldn't be too bad. B squared. What's 15 squared?
125? Or is that
Bigger than
225?
225. So 225, and then A squared,
81.
81, and C squared,
16.
16. Now we need 2 times A times C. Well, let's do 2 times C first. What's 2 times C?
8.
That's 8. What's 8 times 9?
72.
72. Okay, we can combine like terms. What's 81 plus 16?
97.
97. Now we have to bring the 97 over to the other side, and how are we going to put the 97 on the left? By, yeah.
Subtracting from both sides.
Yep, so 225 minus 97. What's that, 128, I think? 128. Let's stop for a second and look at the original problem. Well, let's keep going, but let's see what happens. So 72 cosine beta. What would I do now?
Divide both sides by negative 72.
Divide both sides by negative 72. That's gone. Anybody notice anything at this point? Yeah?
B is going to be negative.
Well, B is 15.
Oh, I meant beta.
Just because that's a negative, it doesn't mean that the angle is going to be a negative when we do inverse cosine. Plus, if it was a negative angle, that would be kind of odd in a triangle to get a negative angle. Anyone else notice anything here? All right, let's keep going then. What's my next step?
Take inverse sine of both.
Take
Inverse cosine. of
inverse cosine. All right, well, let's try. Take the inverse cosine
both.
of
Oh, wait, the bigger number is at the top.
the bigger number is not in the bottom. So we got a domain error. So we either made a mistake or look back at the original problem. What's going on?
Oh, the sides won't equal more. Two sides won't be more than one side.
Right, if you add A and C together, it's not bigger than B. That's an impossible triangle, you can't do that. So I told you side, side, side could have no solution, that's a no solution. Everything we did was correct though, so that's still good to know how to do that. It's just the side, side, side I give you on the test probably will have a solution. So that is how you would set it up. And when you get to that last step and do inverse cosine, it will work instead of not. All right, so next one we're going to look at is writing a complex number in trig form. Now, they just gave us a 6. So what's the imaginary part to that complex number?
0.
0. So if it helps you to write it, you could put 0i. There is no imaginary part to this one. Okay. To write a complex number in trig form, what are the two letters we need to figure out? Yep.
The R
R.
is one of them, and then the Greek symbol. I was the name of it.
Theta. Yep. So we have to find those two things. If it helps you, you can make a picture. That's where 6 plus 0i would be when you draw it. So, what's the radius from the origin to that point? Yep. 6. You don't need inverse tangent because when you're on an axis, you can just count. And when you're on an axis, I'm sorry, you don't need Pythagorean theorem when you're on an axis. You also don't need inverse tangent because whenever you're on the positive x-axis, the angle is always so remember, this is an amount of rotation. How much rotation if you're right there? 0. So that's a 0 radian rotation. So then the final answer is r cosine 0 radians plus I sine 0 radians. That's how you write a complex number and change it from standard to trig form. All right, so let's take a look at converting this from trig form back into standard form. So what we have to do is figure out what the trig functions come out to and then multiply them by 8. That's going to be distributed. So when we're thinking 30 degrees, I know that 30 is an angle on the unit circle because it's a multiple of 30. It's 30 times 1. If this was an angle of like 33 degrees, well then no, I'm not using unit circle. I'm just doing the whole thing on my calculator. But it's not it is a multiple of 30. So got our unit circle, 30 degrees, got our triangle. In a 30, 60, 90, how long is the long side?
Root 3 over 2.
That's always root 3 over 2. And how about the short side?
1/2.
That's always a half. So that means the coordinate for 30 degrees is root 3 over 2, 1/2. All right. So now, cosine is which part of this coordinate?
value?
The x value. So what's the x value in that coordinate?
Root 3 over 2.
That's the cosine of 30. Plus I times, now I need the sine of 30. The sine of 30 is the y value, which in this case is,
1/2.
that's the sine of 30, 1/2. Okay. And you might think, well, I'll just use my calculator and I'll just type in the sine of 30. Well, not if you're on the no calculator portion. You'd have to know the sine of 30. So, all right, now we're going to distribute out the 8. So that's going to be 8 root 3 over 2 plus 8 times 1/2 is 4. And 2 goes into 8 how many times? 4. So the exact answer is 4 root 3 plus 4i. That is the standard form of number 8. All right, so let's take a look at multiplying two numbers that are in trig form. So there's only 2 calculations we have to do. We've got to figure out what the new radius is going to be and what the new angle is going to be. How do you find the new radius? Using the 2 original ones when you are multiplying. Yep.
Multiply them together.
Right. When you're finding a product, you do the product. 6 times 3, your new radius is 18. Now, how do we get the new angle? Using that one and that one. Yep.
You subtract you add the first and second angle.
Yeah. And what do you get if you add 195 to 70?
265?
265. Yep. So 265 plus I sine 265. And that's it. That's all we have to do to multiply those together in trig form.
That's all we need to do?
If these were not already given to you in trig form, that would be a little more work. We'd have to convert to trig form and then do it. But they're already in trig form. So just multiply the radii and add the angles.
Could we see how to put that into standard form?
How to put that in standard form?
Yeah.
Yep. So 265 is not a nice number. It's not a multiple of 30. It's not a multiple of 45. So I'm just going to use my calculator and round it.
Okay.
So to put this into standard form, you have to multiply the 18 times cosine 265. So 18 cosine 265. So that's negative 1.57. And then I need to multiply the 18 times sine 265. 18 sine 265. That's negative 17.93. That is what you get if you multiply these two numbers together and you do it in standard form.
Okay.
All right, so let's find the quotient. This is very similar to the last one. When we find the quotient, what do we do with the 2 radii?
Divide.
Divide them. So what's my new radius going to be?
3.
3 cosine. And what do we do with our 2 angles?
Subtract them.
Subtract them. So what is my new angle?
180.
180. Now, that's one that we could convert into standard form and get a very nice answer because that is on an axis. Right. I won't convert it to standard form. You could do what we did last time, but you would get a very nice answer if you did. All right, so this one was using de Moivre's theorem to raise a complex number to a power. The first step would be to take your complex number and put it in trig form. That's already done, so we don't even have to put it in trig form. In class, we did. All right. What do we do to get our new radius in this problem? Well, what's the radius we have now? 5. And what are we going to do to the 5 to get the new radius?
Cubit?
Cubit, yep. So our new radius is 125. Cosine. What's the angle that we have right now?
90.
90. And what are we going to do to the 90 to get the new angle?
Multiply it by the 3.
Multiply it by the 3. So we're going to get 270. Now they did say standard form, so we can't leave it as cosine and sine. Okay, where's 270 on the circle?
In the third quadrant?
Nope, it's not in a quadrant.
It's on the axis. It's in the negative y-axis.
Right, it's on the negative part of the y-axis. So there's 270. So what would be the cosine of 270? Yeah. So what's the x value of the coordinate for 270 degrees?
-1.
That's the y value.
Oh, sorry. 0.
0. You have not gone left and right. So cosine of 270 is 0. What about the sine of 270?
-1.
-1. We've gone down 1 on the unit circle. So this part turns into -1. I times -1 is -I plus 0. -I. So 125 times -I. So we would write that as -125I. That's how you write your answer. All right, so last problem we're looking at is finding the cube roots of what they give us. Now, since we're doing a cube root, how many answers should we be expecting?
3.
3. Okay, 3 different answers. So, cube root, what does that mean? It means that I can raise something to the 3rd power, and I can get, in this case, that answer that they give me. Right? If you can figure out what z is, that's the cube root of 125 cosine 288 plus I sine 288. Okay, it's the same thing if I said to you, what's the cube root of 13, and you didn't know how to find it. The cube root of 13 means that there's some number that you can raise to the 3rd power, and when you do that, you will get 13. Okay? If you can figure this out, you know the cube root of 13. Same thing here. If you can figure out z, then you know the cube root of all of that. Okay, the first step is to make sure everything is in trig form. Is anything in trig form there right now? Which side? The right side. In class, we never had one where the right side was already in trig form for us. I always made you figure out what the trig form was. Okay, but this one they already gave it to you. The left side is not. What are we going to change the left side to?
Cube root?
Well, it's going to be something in trig form that we have to use Dumont's theorem on. So how do we write a complex number in trig form generically? What does it have to have in trig form? Well, there'll be an I in it. What else? Yep.
A radius.
It needs a radius. Yep. And it needs an angle. Do we know what the radius and the angle is? No, that's what we're trying to figure out. We don't know the answer to the problem, but it's going to have a radius and it's going to have an angle. So that is z. written in trig form. It's going to have a radius and it's going to have an angle, and we need to raise that to the third power. Now, just to avoid, I'm not going to rewrite the whole right-hand side right now. I'm just going to simplify the left. What does the left side turn into with Demoivre's theorem? Yeah.
R to the third, parentheses, cosine, 3 beta plus I sine.
Yep. And now set that equal to what we have. Now everything is in trig form. Okay. What is the radius on the left? Yeah. R to the third. So we're going to take the radius on the left. And what's the radius on the right? 125. So we need to set radius on the left equal to the radius on the right and solve it. And that's going to be our radius. How do we get r by itself there? Yep. And what is the cube root of 125? 5. So now what we know is the size of the circle that our answers are going to be on. All the answers in this problem are on a circle that has a size of 5. But what we don't know is where on the circle. Okay? So we've got, have a good one. We've got to figure out where on the circle are our 3 answers going to be. And if you remember what I said in class, they're going to be the vertices of an equilateral triangle because they're all 3 points. And they're all equally spaced. So if you want to space 3 points equally on a circle, you need to kind of do something like that. 120, 120, 120. They're all 120 degrees apart once we find our answers. So we know the size of the circle. Let's figure out where the 3 dots are going to be. The angle on the left is 3 theta. What's the angle on the right? 288. Now, if that's all you do, and you solve that, you're only going to get one answer. You'll get one of the dots. What do you have to put on the end to make sure you get all the dots?
Plus 360K.
Right, because we're doing degrees, we want to put plus 360K. And what are we going to plug in for the 3 values of K?
0, 1, and 2.
0, 1, and 2. Okay, before we plug anything in though, we should solve for theta. So it's not 3 theta. How would we get theta by itself there?
Divide by 3.
Right, divide by 3, 3, and 3. Now 288 divided by 3, not going to be a nice number. 288 divided by 3. Oh. Oh, it is, right, because if you add up all the digits, 8 plus 8 is 16, 16 plus 2 is 18. As long as you add them up and it's divisible by 3, the whole thing is divisible by 3. You just add the digits. So 96, that's good. So we get 96. And what's 360 divided by 3?
120.
There's the 120 that I was telling you about from the equilateral triangle. All right. So we've got the formula to find all the angles. We know the size circle. That's the same for every answer. We just have to write all the answers. There's k equals 0, 1, and 2 that we just said. And let's write them down. So r cosine. And I'm going to copy that because my answer is going to look very similar. I'm just going to change the angle each time. Okay. So if we plug in 0 for k, what is my first angle going to be?
96.
96. Now, if we plug in 1 for k, what's 120 plus 96?
216.
216. That's my second angle. Now, if we plug in 2 for k, what's 240 plus 96?
336.
336. Yep. And that's where you should stop. If you accidentally did k equals 3, you would be repeating your first answer.
Okay.
So those are the 3 answers to the problem, and they are in trig form. None of those would be nice in standard form because these are not multiples of 30 or 45.